Okay, this session we will talk about the first approach or the first task. This is considered as supervised learning. We call it regression analysis. Some refer to linear regression. So this is one of the supervised learning. Okay, so in the previous week we talked about how do we do the data modeling, and before that we talk about data exploration and also managing your data, how to data. So now we let's suppose we have all the data prepared. Okay, now depending on your task, so the first task that we will look into is called regression analysis. Okay, so I have shown you the concept of machine learning. So what we will do this session, we will look into here, supervise, and then we look into the regression and linear regression here. So we will cover this regression analysis today. So to look at the big picture here, basically we have linear regression is one of the supervised learning beside classification. On the other side, we have the unsupervised learning that cover clustering and also association rules. But for more advanced technique, we can go to ensemble learning, artificial neural network. So this is more into deep learning and reinforced learning. Okay. So regression and classification, they are considered supervised because we have the label or some value that we can consider to model the data. Some data that we call it dependent variable that we can use as a guidance to model the data. Okay, so if you have categorical values, okay, we will use classification. But if you have numerical value, both as your dependent variable. So for regression, your dependent variable would be numerical values. For instance, you want to forecast the profit, or you want to forecast the number of passengers. Okay, so it must be continuous variables. So in comparison to the classification, they use symbolic label as a guidance. So today what we will look into is we look into what is regression analysis. We will look into how to interpret the result and what assumption that we should make. So what assumption means what are the requirement for the data that we have, and what is dummy variable. So in this case, we can also consider categorical values to be your independent variable. And in the future, you may see this ARIMA, which is statistics based, and also neural network, deep learning. So both this also can be used to perform the regression analysis. Okay, so when people ask you what are the other approaches to do regression analysis, so you could use linear regression, statistics, and also deep learning. Okay, This regression analysis also can be extended to logistic regression and also regression tree. So this is more into categorical supervised learning. So this one you will study in machine learning for data science. Okay. Okay. Let's take a look at the regression analysis using linear regression. So for instance, here in the diagram, we have two type of variable. So the dependent variable is the one that we want to focus. And this is the independent variable that we can consider to focus this value. So for instance, based on the diagram here, your salary can be forecasted based on your skills or your certification or the number of time you work or your age. Okay, so we want to forecast this value based on these three independent variables. So whenever you have this situation in which your dependent variable is numerical values and you want to model this data, then this is called regression analysis. Okay, so we have another scenario here. For instance, measurement of the influence of one or more variable on another variable. So that means you could have one independent variable that can affect the dependent variable, or you can have multiple independent variable that can affect your individual dependent variable. So for instance, over here, they say that do parents educational level and place of residence affect future educational attainment? Okay. We have another example here. We want to predict how long does a patient need to stay in hospital. Okay. Or what product is a person mostly likely to buy from an online store? So this is more on prediction. Okay. So if we look at the regression analysis, we say that for your dependent variable must be continuous value, right? So must be numerical value. Okay, for instance, this one is one-to-one. So we want to look at how your certificate or qualification affect the salary or the time that you have, how long you work can determine the salary that you earn and also your age. So this is simple linear regression because we are considering only one independent variable at one time. But if we have many, so this is what we call multilinear regression. Okay, multiple linear regression. But if you are looking into categorical value, so this is symbol, either you happy or not happy. So this is not numerical value. So this is called logistic regression. Okay. For both of these linear, simple linear and multiple linear, we have metrics which is numerical values. But for the logistic regression, we have nominal and ordinal values. So this is categorical value or symbolic values, or we have labels. Okay, so we will not consider this one today. So we'll look into these two. So if you look at the first requirement that we need to have is your dependent variable must be numerical value, and your independent values could be numerical value or categorical value. So the one with ranking or non-ranking. Okay, so this is the requirement that we need to have. For instance, we want to look into this because your independent variable could be in the form of labels or categorical value. So for instance, this one, gender, male and female, and this one is the type of vehicle. So they are in the form of labels. So we want to convert this one into numerical value. So we change them into dummy variable. For instance, if you have female, maybe we could change this one to 0. This is 1. Okay. This one, we could change this one to 0, 0. This is 0, 1. This is 1, 0. Okay. So what we want to show here is that if you have your independent variable as categorical values, so you need to change them into dummy. So dummy variable will hold this value. Okay. I'll show you in the how do we apply this one in the real world environment. Okay, let's take a look at the simple and multiple linear regression. So the only difference is that we look at the independent variable, the number of independent variables that you have. Okay, so the idea for the simple linear regression is that we want to okay, remember that for simple linear regression we have IV, and we use this IV to model your dependent variable. So that means this one, for instance, you want to forecast the how long you stay in the surgery or in the hospital, depending on your age. So the higher is your age, the longer you stay in hospital. Okay, so this is a simple linear regression because we only have 1 and 1. So we want to draw a line. So your line could be represented by using this formula, in which your age will be the x, and this is the slope, and this is the intersection of y if your age is 0. Okay. So for instance, if we have these values, so if we plug in the x, we will get the y. So that means in the future, if we have new value, for instance, our x is maybe 3, so we can just plug in here, then we can forecast your y here. Okay. Okay, for instance, this one is 33. So we just plug in, and this is the estimated length of stay in the hospital. Okay. And the slope that we get here can be calculated. So we need to go back to your maths. How do we measure the slope of the formula here? Okay. So of course, when we say modeling, what it means that we wanted to draw a line that will minimize the error between the forecasted line and also the actual value. So this is your actual value, this is the forecasted. Okay. So there would be any summation of error. So of course we need to put this error here. So plus the error. So the error could be some value that can be calculated by looking into the differences of the forecasted and the actual value that we have. Okay. So for instance, like this, we want to draw a line here. Okay. And if we have this value for the intersection and also the slope, so we can just plug in the value for x here. Okay. And how do we compute the error here is that we wanted to find the differences of the actual and also the predicted value. And we take the square in order to remove the negative values and do the summation here. So the idea is, how do we find a line here that will minimize this value? Okay, so when we say modeling, actually the system helping you to form a formula that will minimize this error. So you give the data, you provide everything, then the system will automatically form the formula in such a way that it will reduce the residual value or the error or the differences or the square differences of between actual and the predicted value that we have. Okay, so this is what we call the sum of square error. Okay, so if I ask you in the exam, how do we evaluate the performance of the linear regression? So we can say that, okay, we can use sum of square error in order to find the accumulated error for the formula provided by the linear regression. Okay, any question? Okay, so if you okay, can you type number 3? Okay, okay, so if you look at the the idea here is that, okay, we go back here. So for us to draw a line here, we can say that we are trying to find the correlation between the x and y, right? Or this one is between x and y, but in the other way, which is the negative correlation. So one of the ways to find how close two variable between IV and also DV is looking into the correlation value. Okay. So the higher is the correlation, either positive or negative, the lower number of error that we get. Okay. For instance, we can use the correlation formula in order to find the correlation between independent variable and dependent variable. But by looking at the value of the correlation, is not enough because sometimes it gives you high value, tapi when we look at the chart, it's not really highly correlated. Okay? So this is the example of how do we use R software in order to look into the what is the correlation between independent variable and dependent variable. Okay. So this is the problem that we will get. I will show you later on how do we get to this point, but I just want to explain to you what happened here. So this is the problem that we get. Okay. So if you have this, that means this is just a comment explaining what is this. So nothing happened here. So, but when you say attach anscom, so basically we are getting the data from the library that already in or in the store. Okay, so here we are getting the data. And then if we show the content of the data, this is what we get. We just type the name of the data that we have. Okay, so we have x1 up to x4 and y1 to y4. So we want to show what is the correlation between x1 and y1, x2 and y2, and so on. Okay, so we have this formula. We have all this series of values. Okay, so if we do this finding the correlation between x and y, so we get this value. So remember that the higher is the value, the higher is the correlation between x and y. So if you look at the value here, almost to 1, and the rest also looks the same. So we can say that all of them are highly correlated. Okay, but there might be some error here. So we need to visualize the content of the data before we can make further assumption. Okay, so here when we type correlation x1, y1, they will take these values and these values, and then they perform the correlation analysis, and this is what we get. Okay, so looking at all this number, okay, let's suppose we want to visualize. Okay, so in here we have this statement in which we will create a 2 times 2 grid. So we will have four places here. So in each one of these, we will try to plot x and y. So they will be filled for all 4. 1, 2, 3, 4. Okay. So once we get this, we will get this output. Okay. So the R software is very easy to use and user friendly, and it can provide you instant diagram plots, so you don't have to use Excel to produce all of those. So if you look at over here, plot number 1, this appears to have a true linear relationship. Okay, but if you look at plot number 2, this is polynomial. And if you look at plot number 3, we have this, but we also have outlier here. Similar to plot number 4, they assume that the line is here, but basically we have this and this. But if you go back to the previous result, all of them give you same correlation value, right? So to look at the correlation itself is not enough. So we need to really look into the plotting. So over here, we can say that only plot number 1 or x1 and x2 has the true linear relationship compared to plot number 2, 3, and 4. Okay. Any question? Okay. We look into another example here. So this one, for each of the tasks, we may require some packages. So for this one, we are looking into how do we perform regression analysis for a case in which this one, the goal is to predict the water yield, the content of the water in the snow. Okay, so given that the data is already exists, so we will install the package, and then we get the data here, and then we say we print the data is the content of X and Y. Okay, so this is one of the ways on how we can obtain your data. So either from Excel or from the library. So in this case, we are getting the data from the library just to show how we can use regression. Okay. So in this case, we have X and Y. Okay, this is the initial data. So what we want to do is we want to change the data here. So that means we want to have, this is the X, this is the Y. Okay. So basically this statement change the name of X and Y to be content and yield. Okay, so if you want to see the content again, so notice that your X and Y already changed here. Okay, so if you want to plot the name of the graph is content. No, you want to plot the, this is your X, this is your Y, and this is how it looks like. So you should be able to see the true relationship here. Ignore this one. Okay. So this is, we are plotting the content versus the yield. Okay. So now how do we model this data? So the objective is to draw a line or to form a formula or to formulate the line that indicate relationship between X and Y. Okay. So we will call linear model. So this is your dependent variable, and this is your IV. So we use this tilde symbol to say that, okay, I'm going to model our dependent variable based on our independent variable that we have. So we will call this linear model, okay, and we will store the result in here. Okay, so when we say, okay, I want to look at the summary of my linear model, so this is what we get. How do we interpret this one is that, okay, we look at here this triple star, meaning that the content is significantly contribute to the data model. Okay, so our error here is that, okay, for a single one we use this one, this error. For multiple linear regression, we use this one. Okay, so this is multiple linear regression. This is single linear regression. Okay, and this is the line that we managed to get based on the model that we generated using the linear model. Okay. Okay. Any question? Let me show you this one before we go to the next one, just to show you that this is doable. Okay, can you see this? Okay.
Yeah, doctor.
The first thing, okay, this is just installing the package. So if you have not installed them, they will install this one. You may have some warning because of the version that we have. In here, they asked me to upgrade. I will say later. Oh, gone. Okay, and then one is install and the other one is to upload into the memory. Okay, so that's why we have two. One is to install and one is to upload. More package. Or maybe I need to upgrade the one that I have is 2004. So they asked me to upgrade. To 2026 version. So so for tomorrow, make sure you have installed the R Studio. So we will go over some practical. So you could use the R software or you can use the R Studio. The R Studio is more the interface is better compared to the R software, but both give you the same functionalities. interval. Oh, okay, so it's quite fast. So we need to install first. Okay, then we will upload the library, but there is no package called. Okay, I might need to do this one. Let me do that one. Okay, let me figure out this one. We'll do the practical tomorrow. The problem with the open source is that when they upgrade the version, then the package that require are not there. So we need to find the solution from the R project. Okay, I'll sort out this thing and we'll should be ready for tomorrow. Okay, let's continue. Next one. Okay, now we go into the multiple linear regression. So for this one, we will have more than one independent variable. So your independent variable could be in numerical value or in categorical value. So you want to model your numerical value here. So this is your independent variable, this is your dependent variable. Okay. So for simple linear regression, it's straightforward. We only have one independent variable. But for multiple linear regression, we have multiple independent variable. Okay. So the task is, how do we estimate this value? B1, B2, and Bk here. For single linear regression, we only have one. So they try to draw a line that will fit most the value of X and Y. But for this one, we have multiple independent variable to model your single dependent variable. Okay. So the aim here is that we want to formulate this formula. And of course, we will have the error here. So we want to estimate this constant value and also the weightage for each of the independent value. Okay. So how do we estimate the value for B1, B2, and BI here? Okay. So first what we can do is that we can change this one to B0. Okay. And we add another constant value here for this one. And this is we set to 1. Okay. So this is just to standardize the formula here, so that your constant value here is represented by the same formula that we have. Okay. So we have all this value for the y, and we want to estimate this. We want to estimate this for any of the value for x1, x2, and x3, so that we can have the value of y here. So this is the area that we have. Okay. So this is your vector, this is your matrix, and this is the coefficient regression that we want to estimate here. And this is the area that we have. Okay. So how do we estimate this? We can use this formula here, and our task is to estimate this because this is the one that we wanted to have. What are the number here, right? Okay, so how does the system estimate the value for the given value x and y? So this is the formula. So where they multiply the transpose of the x value with the x value and get the inverse of this, and then multiply by the transpose of x times y. Since we have the x value and also the y value, this one can be easily calculated. Okay. So how do we form a formula for this? Of course, in the multiple linear regression, it will do it for you. Okay. Over here, we just show to you how it can be calculated. Okay. So for the R software, the way we define function is that, okay, we have a function and this is the name of the function, and we have input y and x. So since this is a function, it will return a value or a vector to your regression here. So we pass the value x and y. So this is matrix, this is vector. Okay, and then once we get the x, we define them as matrix here, and then we will find the formula here by looking at, okay, this is what? This is the transpose of x times x, so that one is this one, and then times the transpose of x times y. Okay, so this one is also, this is the inverse of the formula here that we'll have. So once we get this function, so we can call them later on. Okay, we will show you tomorrow during the practical on how to use this one. Okay, so the main idea here is that this function will be executed when you call the multilinear regression to estimate the value. Okay, so the four assumption that we need to look into here is that there must be true linear relationship between dependent and independent variable, and also they are normally distributed. I'll show you in the next slide. So this is true linear. This is non-linear because we have a polynomial formula here. So how do we check this one? Is by plotting the graph. So we cannot depend on the correlation value. The second one is that there should be a normal distribution of error. So we can use the quantile plot to look at the error here. So this is the QQ plot. I'll show you tomorrow. So we must have normal distribution. So normal distribution, you should have this. And the third one is your data should be scattered consistently across the line. So this is homoscedasticity, in which you will have a similar error here, distribution of your data. So we cannot have this. Okay. So for this one, your regression result will be less impact or less quality. Okay, and the fourth one is multi-collinearity, in which you cannot have two variables that is highly correlated. So for instance, you cannot have this and this, which is highly correlated, because we cannot determine which one will have impact on your dependent variable here, either x1 or x2. So when we have this x1 and x2, which are highly correlated, we need to remove one of them. Okay, because they are highly correlated, so we are unable to determine which one have higher impact on the dependent variable. So these are the four things that we need to check. Okay, and for the dummy variable, for instance, just now we could change the categorical value into numbers. For instance, male and female. Okay, so if we have 3 just now, so we could use 2 bits here. So for instance, we can get this. Yeah. So this one refer to sedan. So this one refer to sport car, and this one refer to one. So that are many ways. So we can use 0, 1 for each one of this to show on and off, or we can assign this one as bits. So this is for this is 0, 0, 1. This is 0, 1, 0. No, 3 bits and 2 bits. So this is 0, 1. This is 1, 0. This is 1, 1. Because we have 3 unique values. But in this case, we could also use binary. Okay, so this is how we change the categorical values into numerical values. Okay, so this is we are simplifying 3 variables to 2 variables, so similar to what we have. So for instance, if this is 1, so both of them is 0. Okay, so we can use this one also. Okay, so but when you do the modeling, you don't have to worry, because the system will convert the categorical values into the numerical values, so you don't have to worry about that. Okay, now we look at how we can use the multiple linear regression. So in this example, we are looking into the medical expenses for 1,338 example of beneficiaries. So in which we want to estimate the charges or the insurance. So depending on the age, the gender, BMI, children, smokers, and in which region. So remember that this is symbol. This is also symbol. So we will change them into dummy variable, but it will be done by the system itself. Okay. So over here we will read the data, and then we we look at the structure of your data frame. So the STR stands for structure, because we have imported or we have read the value into this variable. Okay, we are getting from this Excel file. And then if we do summary, so the summary here just give you the descriptive statistics. So it gives you the mean value for the charges. Okay, so but if we remove this, it will do for the rest of your data that we have. This gives you max, the mean, median, and first quartile and third quartile. Okay, we could also plot the histogram for the charges. So we have high number or the frequency for 10,000 and below is higher compared to 50 to 40,000. We could also look at the correlation between the variable. So we are looking higher to 1. So the highest one is this one. So which means the age is age and charges, they are at least higher correlation in comparison to the other. So this one we are looking into 4 only, because the other 3 is the other 3 are symbolic values, so we cannot measure the correlation values. We can also do the plotting here. So here we are plotting age versus the other. So for instance, this is between BMI and children. So if you look at just now, we have age and charges. So age and charges is this one. So you can compare the plotting here. We have another version of plotting. We have this one. So dia lebih cantik lah. So if we look at the age and charges is here. Okay. So we look at the diagram here. Okay. So the oval shape object on each scatter plot is a correlation ellipse. So kalau dia lebih bujur macam tu, that means higher correlation that we have. Compared to this is more round, and also this, and also this. Okay. The dot at the center of the ellipse indicate the point mean value. So the mean value of your dependent variable. So this one is very useful because you just use this package in order to plot them. You just say, okay, you want to plot the age BMI children charges using the pay panel function that we have. Okay, so you will have fun with this plotting later on. Okay, this is just to have a view. What is the scenario that we have? Okay, now what we want to do is, okay, how do we use the linear model function here? So for instance, here we have the linear model. We state the dependent variable versus the independent variable that we have, and this is the data that we have. So how do we type the command? So we just say, okay, I'm using the linear model. The charges is my dependent variable, and I will model the dependent variable using all the independent variables I get, and I get the data from this insurer. Okay, if you malas to type, you just put dot, so it will take the remaining variable from this data, except this one. Or you could also model the data by just setting 1 or 2 or 3 only here, because remember that you have this plus, so the plus indicate that you are modeling the charges using the independent variable included in the statement. But if you put dot, it will include all. Okay. Okay. So this is the summary of the model. So it says that for every year that your age increase, you need to pay additional 256. Every children that you get, you need to pay additional 475.5. If you're a smoker, you need to pay additional 23,000. But if you are male, so you have less charges. Or if you stay in the region Northwest or region Southeast or region Southwest, you will have less charges. Okay, so this data can be used to estimate the charges value that we have. Okay, so this is the interpretation. Okay, so if you look at the summary again here, okay, so if you look at the summary here, we see that this is the 3-star. Okay, the higher is the star, the more significant is the independent variable contributed to the dependent variable modeling. So in this case, the age, BMI, children, and smoking have very significant impact on your charges. Okay, and there is no star here for the gender, so that means you can eliminate this one for second norm modeling. Okay, and for this one, since we are using multiple linear regression, so we will. So this is the adjusted R square. Okay, so the R square is normally used to look at how good is your data modeling. Means that how good is your data can be fitted into the model that you have created. So the highest value is 1 here. Okay, the lowest value is 0. Okay? The higher the value is your R square, the better it is the model. So when we say linear regression, you can measure them using the sum square error. So this you need to calculate all those things. And you can also look at the R square. So people from the economy or business, they look at the value for R square to determine whether the model can model your data or not. Okay. Oh, yeah, that's all for. So maybe I can show you this one. Let me escape this first. So to show you that this is actually working out, I hope there is no library changes here. Okay, can you see this? So I will try to find my data in the D. Okay, can't open. Okay, I need to find the file. Let me find the file first. My teaching. Okay, I will put in the D drive. Okay, so this is the data that we are using. Okay, can you see the data here? Okay, so this is the Excel file. So I will put them in the D drive. Okay, so I will now import them. Okay, so if I look at the structure of my insurance, so this is, I have to reduce the view here. Okay, so you can see better. So in this statement, I say I will read the CSV file. So the name of the file is this one, and I will say all the string to be maintained as vector because they are symbol. So I set as true. So the sex smoker region, they stay as the symbolic values. Okay. So now I want to look at the summary. So I can do it for individual column, or I can do it for all of them. So for this one, I say summary, provide summary for all of them. So for the sex smoker, they just give you the number of instance for each of the sample that we have. For the numerical value, they give you the descriptive statistics. Okay, you can do the plotting as well, but you need to give space for them to plot. So it will be plotted here. So just one statement, you have this. Okay. And you also can do the correlation between the variable that we have. So this one will give you the correlation value. Okay, so we have the highest one here. Okay, we can also do the plotting here, but we give more space here. So we get this. Okay, so if you want to have better view, we zoom out. Zoom out. Okay, we can use the better one. So we need to install this. So this is one of the library that we can use to install. So we install and then we upload into the memory. And then we plot them. Okay. So you have this. Okay, so how do we model them? So we can use this. So you cannot see anything on this one here, but you can say here. So this one will will give you summary. Okay, so that means we are modeling the charges based on age and so on, so on, so on from this data. So we could also use the same thing, but we say, okay, let's do it for, we remove the gender here. So if you look at here, they slightly change in the values that we have. So that's why in the slide we say that the gender has no significant contribution. So when we remove, there are small changes here, very minor changes. So lastly, we do the summary here. We want to look at the R square. So the R square is this. Okay. Any question? Yes, T. Mr. T.
Hello, Doctor. Want to
Yes.
ask you about this lecture.
Sorry?
Can you hear my voice, Doctor?
Ya,
Clear,
boleh.
Doctor?
Boleh.
Boleh, Doctor. Ni
Ya.
baru Doktor tanya pasal lecture ni, Doktor. Doktor, tadi saya tengok sepanjang lecture ni kita banyak fokus pasal R language, Doktor, kan?
Yes.
So, saya tengok, so majority lah pasal R language. Pasal teori dia sikit je kan, Doktor, kan? Macam,
Yep.
so, dia after this kita akan banyak deep into other language, Doktor. Maksudnya, kan sebelum ni kita just teori saja. Mungkin after this kita other language and then kita punya tutorial pun kita akan masuk pada other language and then kita punya exam pun akan start pada other language. Betul?
No. Nanti the whole session you learn about the theory juga kan, the theory and also the calculation, right? So to look at how it could be applied, so there are a few ways you can use R software ataupun Python. So untuk mempercepatkan pembelajaran ataupun to how do we apply the R software to perform some of the tasks. So we learn the basic syntax and semantic untuk R software to perform some of the tasks that we have. And of course, you will learn some of the way on how to program. Tapi in the final exam or in the midterm, we will test you on the calculation part. So beside the theory and beside the practicality of the concept, you have to know what happened behind the scene. For instance, how do you compute the entropy? How do you compute the IG? Of course, it will not be computed in show in the program. For this session, you compute the sum of square. Macam itulah.
Oh, okay, Doktor.
Ya.
Terus, apa nama tadi? Dalam midterm dia tak akan tanyalah pasal language.
Di dalam course ni, we will not test you on the R syntax or R semantic, because we assume you know the basic knowledge about programming, but we want to show you how you can use the tools to simulate the task that we are discussing in this topic. For instance, regression, classification, clustering, and association rules. Okay, so we try not to teach students only theory or calculation, but also to show how it can be achieved using the pre-installed function that we already have.
Okay, Doktor. Faham, Doktor. Okay. So, okay. So, apa nama tadi? kita, so I need to focus just on calculation lah. For right now, just right now only. For
Yes,
two.
the theoretical part and also the calculation, and of course the command all ready here for the R software. So if you want to go back and refresh and learn more about the R software, it's all up to you, because we have so many books that we can refer to on how to do the R programming. For instance, to display or to plot a graph, ya ada satu buku lagi. So, but in this course, we just take the one minimal expression that we can use to plot the graph that we have.
Oh, okay, Doktor. Okay, Doktor. Faham dah, Doktor. Okay, Doktor. Masih, Doktor, eh?
Okay, sama-sama. Okay, so any other question? Ada. So thank you for the question, Mr. T. I don't know your name because you put T only. What's your name? T.
My name Taufik Gilar, Doktor. Tapi
Huh?
Taufik, Doktor.
Taufik. Okay lah. T. So next time T Taufik lah. Okay, so any other question? The rest? Ada yang baru join, so you may not be able to scan just now. So I will share lah. So tomorrow we will have our tutorial online juga lah. So we will go into some of the things that we left behind last week. So we will continue from there. I will also show you the first part of the lecture yang kita miss due to the unavailability of the library, that the packages that need to be installed. So I need to rectify that one. Okay, so let me share.
Doktor, last question, Doktor.
Ya, 2-3 soalan pun boleh.
Ni Doktor, apa nama tadi? Is it possible, Doktor, yang for the past tutorial and then this lecture note and next tutorial updated in ITIL, Doktor? Saya tunggu-tunggu juga, Doktor.
Ya, boleh. I missed the tutorial last week too, so I will update them today lah, and also today punya lecture. I think the only missing is the tutorial last week kan.
Yes.
Yeah. Okay.
Alright, Doktor. Thank you.
Okay. Any other question? Okay, so boleh scan. So today also I will post your standing for quiz number 1 and quiz number 2. So we'll have your third quiz next week lah. Okay? Yeah. Okay, so see you tomorrow jam 8. Bye.
Thank you, Doktor.
Bradley.
Thank you, Doctor.
Okay. Welcome.
Thank you, Doctor.
Bye.
Thank you, dokter. Bye.
Thank you, dokter.
Welcome. Welcome everybody. So jangan lupa mandi. Pakai air mineral botol saja.